Hey there again. This is the third and final part of Dart programming language tutorial. And in this tutorial, I'll be teaching you about import statements and classes. What is a class? A class can be thought of as a blueprint for creating an object. It can contain properties, methods, and constructor. So properties refer to variables that we can assign to a class, and method refers to functions assigned to the class. And constructor refers to a special function that every class have that allows it to create an instance of itself. You can think of class as a custom data type where you can squeeze in every type of variables into a class and any other type of functions into the class as well. We'll move on to the computer screen where I'll be explaining more. Let's begin this tutorial by learning about import statements before we learn about class. So what I want you to do is go to the left side of VS Code and create a new file inside the tutorial folder by clicking here or creating here. Let's create car.demo. So once we are inside car.demo file, let's create the class over here such that we can access whatever we write. Okay, I made a mistake here. It should be car.dart. All right. So what does import statement do is we can import code we wrote somewhere else into another file. So let's try to do something like, let's just create a variable. All right, let's save this. And what we can do is, whatever code we write here, we can access it anywhere else. So how do we do that? We do that by coming to the top of this file, demo.dart, and we want to import or use whatever we wrote here in car.dart. We can import it by simply writing quotation marks and the name of the file if you're in the same directory. Let's end the import statement. Now we have the reference name variable inside demo.dart as well. So what we can do is we can simply print name. If we do this, it's gonna say car since we've specified that the name is holding the string car. So let's start with classes. So the syntax for creating a class is type class and give the name of the class. For now, let's give it car. And as with functions, it is type sensitive, so every class has to begin with a capital letter. So this is how you create a class called car. Let's save this and use this car class inside our demo.dart file. So what do we do with a class? We can use it similar to a variable. So let's create a variable of data type car. Let's call it car1 equal. And how do we set a type of car is you call its constructor, which is built in. You can't see it here, the constructor, but every class has a constructor built in, even if it does not show anything here. The function is built in. So how do we call the constructor is using this syntax. So what we've essentially done is we've created a car variable of data type car, and we call the constructor so that this returns a car instance. Now we can have access to whatever is inside car. But this is practically useless because the car does not have any properties or methods. So let's create a simple property called, what should I call it? Let's call it number plate. And as you can see, there's some error. It says field inside the class has to be initialized. So what we can do is we can make it nullable to make that error go away. Let's see what happens if we do this. If we were to print the property, we save it, number plate, what it's gonna show is dot. If we run this, it's gonna say null because we have not assigned anything here. So instead of doing that, let's assign a value to the number plate. So if you were to run this code, it should work fine because we've assigned it before it reaches this point in the code. So this is how you can give it variables. But this is practically useless because it does not actually do much. So let's create a final instead such that we can initialize the number plate property before we even create the car. So how do we do that is we can override, this is called overriding the constructor by calling the constructor here. You're not really calling the constructor here, but you're defining the constructor here. And as you can see, there's a red line under the constructor. And what it says is all final variables must be initialized. So let's initialize the number plate such that once we call the car constructor, this variable will have a value. So how do we do that? It's similar to function. You gotta add parameters inside the parentheses. And one shortcut you can use is click on the car variable, the car class constructor, and you can click control dot and it will give you helper functions here. So if you click on the add final formal parameters, it says it's gonna add a parameter here. So as you can see, you are new to this keyword called this, and what this does is this is referencing the car itself and the number plate. So what happens here is when you pass a parameter here, what happens is the constructor will call itself and assign whatever parameter here you sent to the variable or the property of the car itself. So what this essentially means is you can initialize a car by sending in properties, the parameter. So let's try to initialize a car without having to set the number somewhere below the line. So let's try to do this, and as you can see, it is asking for a parameter here. So the first parameter is number plate. So it's a string type. So let's give it a number plate. So what happens here is, let me just save it. When you're creating a car by calling the car constructor, you're saying set the number plate using the parameter which is the string here. So if you were to print out the number plate right now, it is going to print out the number plate which you gave here. And let's give this class another property called string chassis model. And let's add this inside the constructor as well. So what happens here is the same thing. It's gonna take a parameter number plate and a chassis model parameter, and it's gonna assign according to the order. So let's try to give this car a number plate, a chassis model. So what happens is you're sending in the number plate and the chassis model, and if you were to remember what function does, it takes the parameters in an orderly manner and assign it accordingly. So if I were to print this, and let me print one more, number plate, it is gonna print out accordingly. Okay, sorry, this is not it. Should be chassis model. If I were to run this, and as you can see, it has the proper values. So let's move on to methods. Methods are just functions inside of a scope of this car. So let's see, what does a car do? It can honk, and let's give it a body, and let's just say so. Now if I were to call this function, how I would do that is similar to how I would access the properties, is by first typing the variable name, which is car1, and you can access the properties or the function here. So let's call the function. Let's see what happens if we run. It is gonna print out the string which we've passed in the function. Inheritance is a concept in object-oriented programming where a class can inherit properties and methods of another class. So how is this useful? Let's say we've created a class called motorcycle with properties like license plate number, headlights, and a method called honk. And we create another class called car, which has license plate number and the honk method. What happens is you're writing code two times. Motorcycle has the same properties as car. So the problem arises when you are creating numerous other type of classes which can have the same properties, such as license plate number and the honk method. So instead of writing the code many times, what you can do is create a superclass called vehicle, or you can call it can be called parent class as well. And a vehicle will hold license plate number and the honk method, which is both present in motorcycle and car. So what we do is we create this vehicle superclass or parent class, and we are extending motorcycle and car class from the vehicle, such that motorcycle and car class both will have inherited the license plate number and the honk method. And this motorcycle class and car class can be called the subclass or the child class. And you can also create a subclass for the motorcycle class. Let's call it superbike, and it has a method called go super fast. So in this tree structure, you can see that the superbike class will inherit everything from the vehicle class and the motorcycle class. So that is the basics of inheritance. And let's move on to the screen where I'll explain more. Let's implement the classes that was shown in the slide. So let's go to the car.dart file and create the superclass. Vehicle, and this will contain the number plate, and let's just create one more property called. So we have these properties. Let's create a constructor for vehicle such that we can assign the properties when we call the constructor. Final And instead of giving it as unnamed parameters, we can do the name parameters just as we did in functions for the constructor as well. We gotta add the required, and let's give this a default value of 100, which you can do it by writing the syntax. And we have created a vehicle class, so we want to this car class have number plate, and so does vehicle. So what we can do is extend the vehicle class from the car class, and it says there's an error here. For now, let's remove the number plate from here and clean up the constructor. And when you press Ctrl and dot, it's gonna give you helpful functions. So for now, let's add the first one as well. Remove this. And let's check one more time. It says add final formal parameters. So, okay, instead of doing this for now, let me explain it to you in a older method, which is adding the dots here, calling the super constructor here. And the super constructor requires a number plate and a horsepower. So for the super constructor, what we need to give is the number plate. And let's give it an empty one for now. So what this simply means is your car class has a constructor, and since it's extending a vehicle, you have to call the constructor of the superclass as well. So this is what is happening here. And we are assigning an empty value for the super constructor. So let's go back to the main function, and let's create the car here. And clear this for now. And this requires a string parameter. Let's give it chassis model, and let's see what happens when we print the super constructor's number plate. As you can see, the car1 variable has access to number plate, which is found in the car's superclass. So we can print the number plate here, and if we were to print it, it's gonna come out as nothing because we've declared that the super constructor will have a number plate with nothing inside. And we can statically type here as well, but this is kind of pointless because every other class which extends the vehicle will have a static number plate. We don't want to be doing this, so let's pass in a number plate to the car constructor such that it can pass it to the vehicle as well. So how we can do this is by giving it another parameter. Let's call it string number plate. And there's a difference between sending in this .chassis model and a string number plate, because chassis model is a property of the car class, but we don't have any number plate inside the car class, but it exists inside the superclass. So we can pass in a parameter just like this without adding this keyword here. And once the car constructor receives the string number plate parameter, we can pass it to the super constructor from the car constructor. So let's do exactly that and pass the number plate parameter to the super constructor. And let's pass the number plate from when we call the car constructor. Let's print. Okay, it prints out the number plate. So let's create another car instance and give it the same parameters. Copy it, paste it. And there's a concept you can learn, which is, let's check if car1 is equal to car2. If it is, let's print out if not, so if we were to run this, let's see what happens. It says there are different cars. So even though we are passing the same parameters to the car constructor, every time this constructor is called, it's going to return a new instance of the same car object. What this means is, in real world terms, you can have the same name as another person, but that does not mean you're the same person. So they can have the same properties and same methods, but it will create two copies of different objects. Moving on, let's create another class called motorcycle, which will extend the vehicle as well. And the motorcycle, as you can see, the dart tells you that it has to inherit some properties, which is the number plate. And let's give the motorcycle a simple property like frame model. Instead of using this, let's give it into the named parameter. And what this means is you're extending motorcycle into vehicle. And let's say a motorcycle can honk as well. But for now, let's remove honk for both and see what happens if we create that method inside the vehicle. And when it honks, let's print out the horsepower as well. So if we were to come back here and create a car, and since we are using horsepower as well, what we can do is, let's remove it as a default value and add a required such that every vehicle class will have horsepower, and the super constructor also needs to have the horsepower. And since we are passing the horsepower to the super class, we also need to make sure when the car constructor is called, we have such a thing called horsepower. So we call the horsepower and pass it to the super constructor. And for motorcycle as well, we need to call the super constructor. Let's do super. Instead of calling it here, string. First, it requires the number plate, and also it requires the horsepower. And let's pass it to the super constructor, which has number plate and the horsepower. So it's all set now. Let's fix the car constructor first, since we've added that we needed horsepower here as well, 200. And let's create a motorcycle class, 1. It requires a frame model, which will give, and a number plate, and it also requires horsepower. So we've created car class and a motorcycle class, and since they both extend, the vehicle class will have access to the honk function as well. So let's call the honk function for both of them. If we run this, we have 2 different values because both of them have a super class which have different horsepower. And one more thing that you can do in inheritance is override the methods of the parent class. So if we were to have different methods for the honk class, what we can do is, let's say you want to change the method for the motorcycle class, you can override by writing this syntax, and below it write the name of the function you want to override, and you can create a different implementation of the honk method. For now, let's just print so when you call the honk function from the motorcycle class, what it does is it will print the honk function with the new implementation. Whereas for car, it does not have any override statement for honk. It will default to the method of the superclass. So if I were to print this now, there's a difference. So moving on, let's create one more class called superbike, and it extends the motorcycle class as well. Let's create its constructor, and as you can see, we don't have to use the super constructor this way. We can just call it from the parameter. So what this means is you're passing the frame model to the super constructor directly from the superbike's constructor. So we have all this set, and let's create a new function for the superbike. Technically it's method. Let's call it go fast, and this function will return. It won't return, it will return a void, but let's just keep it simple and print. And let's create a property as well. Now you have to pass a parameter to assign the property. We have set the superclass now, and let's create an instance of the superbike. Let's pass in some properties here. We have created a superbike instance in the variable superbike1. Now let's clear this for now. the superbike1 variable should have all the properties and methods of the motorcycle class. And since the motorcycle class has all the properties and methods of vehicle, the superbike will have properties for both motorcycle and vehicle. Let's see what happens if we were to print the nitro boost, which is only present in superbike. And let's access the new method which only is available in superbike. If we were to run, it's gonna print whatever we give the body for go fast method. But here's the thing, superbike will have all the properties and methods from its parents as well, which is honk. And if we were to do this, it is gonna print I am a bike, since the superclass of superbike is a motorcycle, and we have overridden the honk method in the motorcycle class to print this. And when we call the honk function from the superbike1, it won't reach the vehicle's honk method, since it has been overridden by the motorcycle class. Let's look at interfaces. Firstly, let's clear all this. We can delete the car.dart file as well. For now, let's not delete it. We might need it. So let's create breathing.dart. Let's import that file here. So let's create some interfaces. Firstly, let's create something called a class, and we'll name it air breather, and it will have a function of breathe air. Let's just give it a body as well. Let's create another class called, we have a function called so we have two classes, air breather and water breather. Let's say we want to implement a frog class. As you know, a frog can breathe in air and water as well. So what we can do is we can extend, we'll see what happens if I do this, and it can do water breathing as well. But how do we do that? We can't extend in this manner. So what interfaces, we can use these two classes as interfaces. What interfaces can do is allow you to take the functions from each of these classes and implement it in the frog class both at the same time. And how you can do that is, this is one of the properties of interfaces, but there's more. For now, just let's look at implementing for both air breather and water breather. Now, it says there's a missing implementation for both of these classes. So what we can do is control dot create these two overrides. So what implements does is it will force the frog class to override any functions that the frog class is implementing from. So air breather has breathe air and water breather has breathe underwater functions. So when we implement from them, we have to override both the functions which we are implementing from. So if we were to remove this, we don't have to override the breathe underwater. And for now, let's just make it back to as we were and create the missing override. And we have to create our own implementation of the function here. So let's try to create a frog class in the main function. And let's try to call the breathe air function. If we were to do this, we won't be able to print this function because implementation of any classes is just saying that this air breather class must have a function which is called breathe air. So when we implement a class, what we are saying is we are just giving it a guideline of what kind of methods it contains or variables. If you were to say, it will ask us to make sure there's an implementation of this variable inside frog class as well. So for now, let's just clear this. All you have to know is if we were to implement a class, we have to override what if the frog class were to implement air breather, we will have to override all the properties and methods from the air breather if we were to implement it. So writing this is practically useless for now because it will never look for the body inside breathe air function. So we have to write our own implementation of this function which we have implemented from air breather. So for now, let's write and we have to write another implementation for water breather. So now if we were to call the breathe air function from the frog class, it will give us whatever we have implemented using the implementation of air breather. So this is what it means to be an interface. An interface will tell whichever class it is being implemented from about all the methods and properties that it should have, and it won't pass whatever the method does to the one that is implementing that interface. In this case, air breather and water breather act as an interface for the frog class. Lastly, let's talk about abstract classes. Firstly, let's clear all this and create an abstract class. Let's call it a machine, and it will have a property or a function called switch on. For now, let's just keep it empty. So what our abstract class is just an idea of a class, and it cannot be instantiated, which means we can't. It's just a general idea of what a class should have, and this should be implemented or extended only. So we can't create something called machine, or let's create another one for that matter. Let's create it as Wi-Fi interface. So there's no such thing. It's a general term, what it means to be a Wi-Fi interface, whereas if we were to create a class called mobile phone. This is a concrete example of a real life object. So a Wi-Fi interface can have what you call, let's just give it a method, connect to Wi-Fi, and let's just say that this is empty as well, and use this as an interface. So let's see, machine has a function called switch on. Let's say if we were to call switch on, we will print. So whenever we extend this machine, it should have this method as well. And if we were to implement machine, the class will be forced to override this switch on. So let's try to extend machine such that a mobile phone has the ability to switch on, and let's also give it an implementation for Wi-Fi interface such that all mobile phone must have the ability to connect to Wi-Fi. Let's do this, and if we were to create an instance of either of this class, it will not allow us to create anything of such sort. So let's try to do that. As you can see, it will not allow us to create an object from the abstract class. If we were to do that for machine as well, it will not allow us to do such a thing. So you can think of abstract class as something to be as the super class of something else, and it cannot be an object on itself. So as you can see, once we've implemented Wi-Fi interface, we have to create our own implementation of the Wi-Fi class. Let's try to do that by simply giving it and let's create an instance of mobile phone instead. And we have access to both connect to Wi-Fi, which is our own implementation in mobile phone, and switch on, which is extended from machine. And let's make another class called laptop, and it extends, let's give it implementation instead, Wi-Fi interface. And now you can see laptop must have its own implementation of this function. So let's do that. And instead of printing this, we can write our own body for this function by saying now let's call create a laptop object, and now let's call their methods, which is Wi-Fi and this should have their own implementation. So you can see they have their own implementation and since mobile phone is extended to machine, it does have its method accessible from mobile phone as well. So we can do switch on as well. If we were to do this, it says I am being switched on. Now you can override the function here as well. And you can put in your own implementation for the extension of machine. And if you were to come here and run this again, it will change as well. So now we can see that abstract classes are just a way for us to design a superclass without it being able to create an object in itself. That is all for abstract classes, and that is all for Dart Basics. We'll be moving to learning about Flutter starting the next video. Until then, see you soon.